I'm Rohit and I'll be presenting our new method, Unified Concept Editing, to simultaneously erase, debias, and moderate concepts in diffusion models. Often, you wish that image generation models would not produce a certain kind of an image. These models sometimes tend to exhibit representational bias towards a particular gender or race. For example, we found that on an average, 98 out of 100 images generated with the prompt picture of a successful person are male, and 96 of them are Caucasian. These numbers were pretty consistent too. So far, there have been two main strategies to address this: sourcing responsible datasets with carefully captioned images and retraining the model. However, this can be an expensive process given the resources required for retraining. Second, there are model editing methods that can either erase or reduce built-in biases in these models. We could apply multiple editing techniques sequentially on a model to achieve a unified debiasing and erasure effect. However, we need to be mindful of the compounding limitations with these methods, such as interference. Sequential model editing could amplify interference effects and result in degraded model performance. We wish to build a method that can unify multiple types of edits, such as erasure, debiasing, and moderation of concepts, preferably all at once. A method that allows more precise edits with minimal undesired interference, and the one that scales to number of edits such that multiple concepts can be edited at once. We propose our method, Unified Concept Editing, as dubbed UCE, for editing concepts in diffusion models by manipulating the cross-attention modules. First, we identify the concepts that we wish to edit and steer their output to a different value V star. Additionally, we also define a set of concepts whose outputs are preserved during the edit. These objectives can be minimized in a closed form approach, and through this unified framework, UCE can flexibly apply different types of edits by defining appropriate V star objectives, whether that is reducing gender bias, moderating toxicity, erasing a style, or other goals. When erasing artistic styles or a concept, we steer the cross-attention output associated with the artist's name towards a generic concept like art. This rewrites the model's knowledge related to that artist. Previous artistic style erasure methods are efficient but often unintentionally degrade the quality for unedited styles. In contrast, UCE minimizes alteration of unrelated concepts, and qualitatively UCE achieves the highest clip performance and lowest image similarity distance for such concepts compared to the original model. We can see that qualitatively that UCE maintains high sample quality for untouched concepts while effectively erasing the edited style. When stress tests, UCE demonstrates strong erasure with minimal interference to other unintended concepts at scale. Specifically, UCE can efficiently edit up to 400 unique concepts before degradation starts. And we see that qualitatively at 400 simultaneous edits, UCE starts interfering with undesired and unedited styles as shown here. To debias concepts in diffusion models, we alter the cross-attention output magnitudes for the concept across the direction of the attributes that we wish to debias across. A key challenge is determining appropriate magnitude scales, or the alpha shown here. We propose an iterative method where users define the target bias ratios for the concepts that they wish to debias and the attributes that they wish to debias against. We first sample the current model to measure bias ratios. Then, we edit the concept's attention to adjust attribute directions by eta proportional to the deviation from the target ratios that the users define. This continues until the bias ratio converges within the tolerance of the target. The iterative approach here allows dynamically calibrating the edited magnitudes based on measured bias. By adjusting the step size eta, we can tune edit aggressiveness versus the convergence stability. This iterative approach enables users to efficiently debias diffusion models across race, gender, and other attributes. We demonstrate UCE better matches the target diversity ratios compared to prior debiasing methods. Over repeated trials, UC also shows less variability in attending bias reduction. We define moderation as a method to reduce the likelihood of a concept to occur. Therefore, we replace the cross-attention output of the concept with that of an unconditional prompt. This allows for moderation of particular concept. With 80% moderation, we find that UCE has a strong effect when editing multiple unsafe concepts. We also notice that our method has a strong clip alignment on COCO post-editing, while also maintaining the distribution as close to the original model as possible. Thank you for the opportunity to present our work. We encourage the audience to visit our project website for more details.